Hello and welcome to iPhone app development. My name is Jawad Sheikh. I'll be professor for the term. What we're going to do is take this course from a Java developer's perspective and convert our knowledge of Java into the language of Objective-C. So we're going to learn how to do iPhone app development in the language of Objective-C. We're going to take our knowledge and our experience from Java and turn that into apps from week to week. We're going to build a number of awesome apps together, and we're going to walk through them line by line together. So you'll find that a difficult language like Objective-C won't be that difficult to learn as we progress through each module together. So have a look, try out some of the code. You've made a great decision in taking this course. Developing apps these days is such a lucrative field, and I cannot tell you how much you will gain out of taking this course and building these apps that we're going to build together. There is a lot to learn in this course. It's not an easy course, and you will have to put in the effort to build every app that we have together. Suffice to say that as long as you put in the effort, you'll be able to build some amazing things that you'll be able to put on your portfolio to show your prospective employers and make a ton of money in the end. What we're going to do is we're going to take this course from a Java developer's perspective and translate it into the language Objective-C. Objective-C is not an easy language to learn, but once you get into learning this language, it will get easier. I can tell you when I first started learning iPhone app development back in 2011, it took me 3 weeks to figure out how to make a button and click on that button to go to another page, because there just wasn't enough documentation out there. But suffice to say, I will make it a lot easier for you as we go through the different apps that we are going to build week to week, and you won't have that tough learning curve. But the nice part was, once I learned that, everything else fell into place, and there was a snowball effect, and I was able to build apps faster and faster and faster and build some really cool things. And I hope you will also learn to build a lot of cool things as well. So what we're going to do is we're going to start off with taking a look at Java objects that we have built over the course of our terms and translate those into some Objective-C objects. So let's move on to this first exercise where we're going to look at a few objects in Java and convert them into Objective-C. All at the same time as well. So what we're looking at here on the left-hand side is we have a Java class called rectangle.java. We have public class rectangle. We won't worry about the imports just yet. Within it we have 4 variables: length, width, area, and perimeter. They're all ints, they're all private. We have a constructor, a default constructor, where we set width and length to 0. And there's a reason why I'm using this.width and this.length. And you're going to see why when I get into the Objective-C code. I have another constructor, a public rectangle. I'm passing in length and width, and I'm setting the length and width accordingly as I'm passing in, so that when I'm instantiating, I'm passing that in. Now I have 2 methods here, calc area and calc perimeter. So I'm going to calculate the length, the area as length times width, and return the area. I'm going to calculate length, 2 times length and 2 times width, and return that as well. And I have a little comment here that says, assume all getters and setters are created, because we all know how tedious and painful it is to create getters and setters for all 4 of our variables. So we're going to assume that we've done the get and the set, the get and the set, and the get and the set for all of the variables already. So we'll assume that, because the lines of code we're going to use for creating our getters and setters in Objective-C are really simple and a lot less painful than what we're accustomed to with Java. There's also another method down here at the bottom, print stats. And so we're going to print out the word rectangle stats and then actually print out the length, width, area, and perimeter. And that's our Java class. Now the trick here is we want to convert this Java class into an Objective-C class. With Objective-C, like in the C language, we actually have 2 pieces of the puzzle for any sort of, and I don't want to say object, because in C we don't have objects, but that's the closest thing I can think of for C. In Objective-C we have objects. So what we do here is we break up the object into 2 pieces. We have the header file and we have the source file. So the header file, like in Java, we want to name that file similarly to how we would name our our object. So since our object is called rectangle, we're going to say that we're going to assume that it's called rectangle.h. Right? And notice the spelling, I'm matching the spelling as well. So rectangles over here and rectangles over here. In the source file, I'm going to assume that this file is called rectangle.m. So like I said before, in C, we use a .c file extension. In Objective-C, we use a .m file extension. And now, we're going to start writing out our code. What I like to do is I like to start off with the header file, and then what I'll do is I'll write out my header file, and then I'll pause. I won't finish the header file, but I'll pause and I'll jump into the source file, the .m file. I'll write out the code for that, and then I'll go back to the header file and finish it off. And you'll see why I want to do that right now. So the first thing you want to do with the header file is you want to decide what goes into the header file. And typically what goes into the header file are our definition for our variables and our definitions for our method declarations. So what I typically do is I'll do the variables first and then do the methods later. So that's the way I break it up. So our first step in this is to import the foundation class. So I'm going to say import foundation/foundation.h. That basically says, let's bring in anything from the foundation class that we need, such as arrays, strings, ints, floats, doubles, etc., etc., etc. Anything related to the foundation class. Now, we can go ahead and we can define our object. So we're going to define what exists inside the object. So we're going to use this keyword called interface, but we're going to say @interface, and our object is called rectangle. So we're going to say @interface rectangle. And if this was a Java object, we would have simply said good enough. But because it's Objective-C, there's one luxury in Java that does not exist here in Objective-C. So like we said earlier, all objects are a child object of object. Right? In Java, we said that object is the parent-most object of that language. In Objective-C, NS object is the parent-most object of this language. So by default, in Java, we are really extending object. Whenever we do public class rectangle, we are really saying extends object. But because everything extends object, there was no need to write it. But here, in Objective-C, we actually have to write it. So we're going to say extends, which is what the colon is for. So the colon says extends, that's what it means, NS object. So we're saying extends NS object. So that's the first step, is to define what our object is. Now, the next step is we can go ahead and we can define the variables inside our class. And we're going to say we have length, width, area, and perimeter here. So we're going to say NS integer length, NS integer width, NS integer area, NS integer perimeter. Those are our 4 variables that we have inside the class. And that's typically sufficient for defining our variables. But there's a 2-step process to this in the header file. The first is we define what our variables are, and the second part is to define our function prototypes for our getters and setters. So we don't define the getters and setters piece by piece, but we still have to define that we are going to have getters and setters for our variables. And so that's the next step. So we're going to say, outside of the closing curly bracket, we're going to say @property NS integer, and we'll say length, @property NS integer width, @property for area, and finally add property for perimeter. I typically copy and paste, which I will over the course of the term. But now what this is saying is we have gets and sets for all 4 of these variables, but right now we're defining just function prototypes for these. That's all we're doing. If we had something that had a pointer in it, like an NS string, we'd go a step further and define memory management characteristics for it, like how we want memory to be handled for each of those variables, but that's for our next example. Now, typically we'll end off our object with the end keyword. And that essentially is our header file for now. There's one more step that I mentioned earlier we have to add in. We'll add in after the fact. So if I go over this again, we typically import the foundation header file in order to get access to the items that are available in foundation to make it easier for us to work with. Then we define our interface for this object. This one's a rectangle, and its parent object is NSObject. And we don't have that luxury that we did in Java. We cannot just assume that we are extending object in Java. We have to actually physically say it. Our next step is to open and close a curly bracket and define our variables. And once we define our class variables, then we can then go ahead and define the property declarations for them. These property declarations are essentially statements that will say, I'm going to have getters and setters for each of these variables. And these are the function prototypes so that objects outside of this can access these methods. And then we end off with the end keyword. Now, what we do is we're going to leave that header file for now and jump over to the M file. And inside the M file, what we typically do is we're going to start defining the object as well, but the first step, as you may have seen in C, is to import rectangle.h. Something you saw in C as well. Now in C, we would have included stdio.h, but instead we included foundation.h. And the thing is, because we included foundation.h in the header file, it is implied that it's going to be included here in the M file, because it sort of trickles through down to this file because we're importing rectangle.h. Now what we do is we're going to start defining our object from an implementation side of things. So the header file's purpose was to define our object from a structure side of things, so what variables are there and what methods are there. Now we're actually going to implement our code in the M file. So we start off with a special keyword, just like we did in the header file, but it's going to be at implementation. So we're going to say at implementation rectangle. We don't have to say extends NSObject here anymore because it's already done in the H file. So we're just going to say add implementation rectangle, and that will basically be saying here we are going to begin the code for our object. And what we're going to do now is actually implement our getters and setters. Now in Java, you would have written out get and set, get and set, get and set, and it would have been a painful, tedious process, right? Here, we're going to do it with one line of code. We're going to say at synthesize, and synthesize all of our variables, so length, width, area, and perimeter. Now, wasn't that a lot easier than writing out get and set, get and set, get and set over and over again? That's it. Boom, we're done. We've just created gets and sets for our variables. What happens here is that the compiler, when we hit compile, will actually look at that line of code and generate the get and set code for us behind the scenes. So we'll never see this. We'll never see the get and set, but it will be implemented for us behind the scenes in the binary. So we don't have to worry about it at all. Now there are times where you want to create your own get and set. You may have a reason for it. One example is when I use the accelerometer. if I want to get or set a value for, let's say, XY locations of where an item is that I'm moving around on my phone through the accelerometer, then I might override the set method for that variable so that every time it receives the value from the accelerometer and sets it directly. So there are instances where you need to have your own custom set and you still have that capability. You can still go ahead and write out your set method or your get method as you need to. So you just have to start typing it out, typing out the method, and it'll override whatever is in the synthesized category. Okay. So that is it for our gets and our sets. The next step is to actually start creating our constructor. Now, what I want to do is I want to start off with the constructor that will take in the variables, so length and width. So I'm going to start off with that constructor. And constructors are typically written in a certain way. So I'm going to start off with writing out this constructor. I'm going to say its return type is ID, because we don't know what type to return. We won't know it until compile time. So we always return ID, the anonymous object. And all constructors start with the word init. So in this case, we always start with the word init. We could expand it to be more detailed, like saying init with data, or init with length and width, or init with frame. We have that option to do so. In this example, I'm just going to call it init. And my first instinct is to pass in the length. So I'm going to say init, put in a colon. It's in NS integer, so I'm going to define the type, so NS integer in round brackets, and then type in the name of the variable. Len is what I'm going to use for the length. Then what we want to do is we want to add in our second argument, which is width, but we need to provide a label for that variable. I'm going to make one up. I'm going to say the width, for lack of creativity, and say colon, and then its type is also NS integer, closing round bracket, and just say WID for width. So here I have defined my constructor. The keyword here is that it has an ID return type. Its method is called init, and we're passing in length and width, but the second argument has to have a label. So the width is our label. And we're passing in len as our length and width as our width. Okay? Now, the following steps are what we typically do in a constructor. The first thing we do in a constructor is called the parent class's constructor. So we're going to say self, which, like I said, is another word for this. So we don't use this in this language, we use self. But I also said that we use self very heavily in this language, whereas in Java, we never used it very often. Right? Everything is considered self. Whereas in Java, we would have had to say this dot this dot that, and the other thing over and over and over again. We don't have to do that in Java, but we do it here. So we're going to say self is equal to super init. So this is essentially calling the constructor for the parent object, the super constructor. And the super constructor resides in NS object because that's the parent object for this object here, right? Now what we want to do is want to check to see if this was successful, calling the parent constructor. So we'll say if self, or if self does not equal nil. In fact, I'll do that. All right. Now, instances where self might actually be nil might be in dire situations where you have 50 apps running at the same time, all sucking the life out of your phone, and it's crying for help. You actually see sweat and blood coming out of your phone, and there's just not enough memory to go around with this app, and to be able to request memory or be able to do anything with the app, you basically crippled your phone. And in that case, It may return nil because it just doesn't have the capability to actually go in and actually do anything further until you shut down some apps that are running on the phone or even reboot your phone, right? So that's one example. But there may be times where that line may fail, and you want to be able to handle it. You don't want to start setting your variables or doing anything with it, because at that point your phone is basically crying for help and saying, hey, I can't do no more. Right? So that's one example. But we also want to test. We always want to test for it when they're instantiating something. But assuming this is successful, we can go ahead and set the width and the length. So we'll say self set width, and we'll pass in WID for the width. And we'll say self set length, and we'll pass in len. Okay. So here we're just setting length and width. That was the purpose of this constructor. We want to set length and width. So if we look at the Java object on the right, on the left, we're setting width and length. Here on the right, the Objective-C, we're setting length and width. The only thing left, and we don't see it in the Java, is we have to return something. Because our return type is ID, we have to return something back to make this method happy. So all we're going to say is return self. So we're going to return self. So the caller of this constructor will receive the object back formatted with length and width inside of it, ready to go. Now that was the constructor where we passed some stuff in. Now I'm going to go back to the constructor that's easier to work with, the default constructor. I'm going to show you something that we don't typically do in Java, but that we can do in Objective-C. So above it, I'm going to create the default constructor. Right, so I'm going to say ID init. Okay, so I'm going to say ID init. And here, normally we would write out the same thing. We would say self equals super init. We would say if self, and so on, set our length and our width. Right? We would say that. But we don't have to, because it's already been done in this constructor. So instead of that, I'm going to say, in the end we return self, so I'm just going to say return self init, passing in 0 and the width 0. So what we have here is we don't have to reinvent the wheel. We've already done it inside our other constructor. We are allowed to call other constructors inside Objective-C. In Java, we couldn't do that. We could not call other constructors inside Java. In fact, we had public rectangle, and we had public rectangle with length and width. There's no way to call this other constructor. Right? But here in Objective-C, we can. We have the capability to call the other constructor. So it's just treated, it's nice because it's treated like another method, but it also is special enough to be a constructor at the same time. It still has those special characteristics of a constructor, which is really nice and really convenient to have. So at this point, we've done our constructors. Our next step is to define our calc area and calc perimeter methods. So we move this further down. Let me open up some extra space here. And let's start with calc area. So we start off with our dash. Our return type is NS integer, because we're doing public int calc area in the Java side of things. We'll say NS integer is return type. We'll say calc area. We're not passing any arguments into this method. We're simply going to do the calculation and return the value. So I'll say int a is equal to self.length times self.width, and return a. And that's it. So this calc area method here in Java is also written like this in Objective-C. Very similar, if not the same, except for the word self and the method declaration. Otherwise, it looks like the same method. If we go on to calc perimeter, so we'll say return type ns integer, calc perimeter, I'll say int p is equal to, and I'll simplify it further. I'll say 2 times, and then self.width plus self.length. So I'll write a bit differently than what we have in Java, but still the same thing. And just return p. So same idea. We've basically done our calc perimeter method here, that same as what it looks like in the calc perimeter method for Java. I simplified the equation a bit, but for less typing. But yeah, it's the same method. But what I really want to focus your attention on is the last method, print stats. So we're going to print out all of our stuff back to the screen. And because we're not really doing an iPhone app here, so we're not using labels and text boxes to print stuff back to the screen or alert boxes, we're going to print stuff to the console. So create a method called print stats. It'll have a void return type. And instead of using printf or system.out.printf, we're going to use nslog. And pass in some text. So our first line of text was rectangle stats. And now we want to print out the length. So I'm going to show you two ways to do this. One will be the short and simple way. So we'll say nslog, and we'll say length, colon, and %d, just like the %d from printf for C and Java. And we'll just pass in self length. And notice how I wrote it differently here. There's no particular reason for me writing it differently here, other than to illustrate to you that this is how you would also retrieve length. I could have said self.length here, and it would have done the exact same thing. But just so I can illustrate to you how things are done differently between the dot syntax and the bracketed syntax, just want to show you another way of writing things. So I'll use the bracketed syntax for this method here. But yes, this is how we would retrieve length, how we would print the length to the screen, to the console. Now the long way would be to put this all into a string and then print that string to nslog. So I'll show you that way. So I'll say nslog, and even before that, I'll create an ns string, and we'll call it star sw is equal to ns string with format, and we'll have width and %d, and pass in self width. And notice the double brackets. And then do an nslog for sw. A little bit more painful, but sort of spreads out everything, stretches everything out, and shows you all of the entire operation of what's happening there as well, using string with format. All right, so we printed out length, we printed out width. The last two things to print out are area and perimeter. So we'll print those out. I'll use the easier way to do that. So we'll say nslog area, and then %d, and self area, nslog perimeter, %d as well, and then self perimeter. Right? So at this point, we have printed out everything that we need to print out for stats. Now you notice that in the calc area and calc perimeter, I didn't really save it to area and perimeter, but we could modify this class to support that and work with it. But the whole purpose of the exercise was to be able to illustrate different ways to print things to the screen and do our calculations and whatnot. The only thing we're missing here is the end of the file. So we'll just say at end to end off this object. So we've completed the M file for this class. And now what we need to do here is go back to our header file and finish off the header file. So if we return back to the header file, and we saw that we defined our property declarations and we defined our class objects. At this point, if I was to instantiate this object and I wanted to call any of the methods that were in the object, I wouldn't be able to. What'll happen is that another object will come along, it'll import rectangle.h. And it might want to do init or it might want to do print stats. But it won't be able to because the header file is our barrier. It's our level of security. It's our public and private in a way. Because I don't put the method declarations here, then what happens is that the header file will not be able, the object that wants to retrieve this method won't be able to access it. It's considered private. It then becomes public once I define the method here. So I'll start off with print stats. And what I like to do is, the reason why I write this first is because all I have to do is just copy and paste. And put a semicolon at the end. So now the method print stats is available to another object if they import this header file. If I go to calc perimeter, I do the same. Now, calc perimeter is available to another object. Same with calc area. And now the constructors. See, what's interesting about the constructors is that if I don't include the constructors, then what it does is it creates its own default constructor that's empty and does nothing. And so that way you can still run a constructor, but now you wouldn't be running the constructor we have here. So that's why we have to bring our constructor prototypes into the header file so that it's accessible to the object that imports this header file. And now the object is complete. Now the header file has all of our method declarations. It has our property declarations, which is also a function prototype of get and set for each of our variables. Similar to these lines are function prototypes for the methods that are in the object. But also we have our our object declarations, our variable declarations. We have our declaration of our object, rectangle, it's a child class of NS object, and we're importing foundation.h. And so at this point we have actually built out an object. We've taken rectangle from Java and converted it into objective-c by breaking it down into two pieces. Breaking it down in terms of our header file and in terms of our code file, our M file, so to speak.